Hi everybody, in this session we will discuss the fourth problem type in TSD, that is trains and crossings. Let's consider a particular situation to understand this better. Say we want to calculate the time taken by a train when it is entering a particular platform. Let's represent this by way of a diagram. See the pictorial representation shown here. Notice that the train has been depicted at two particular instants. One is called the just before crossing instant, that is just about when the train is entering the platform. The second instant is called the just after crossing instant. At this point, the train has just about exited the platform. Now, crossing time is the time interval between these two particular instants. That is, this is the time that the train would take in order to completely cross the platform. Note that this crossing distance will include the platform's length as well as the train's own length. This is an important point to keep in mind. Whenever we deal with problems on objects crossing other objects, the crossing distance must always be taken as the sum of lengths, and we can also use this in the formula distance equal to speed into time. In this particular case, the crossing distance will be 250 meters. As the platform is stationary, we don't need to invoke relative speed. We simply use the train's own speed. However, since the distance is in meters, we will convert the speed into meters per second. Using this, we can see that the time taken by the train to cross the platform is a mere 12.5 seconds. Wonderful. Now let's try and apply this concept in a few problems. Consider the first question. Here, the train is involved in two crossing situations, once with a stationary man and again with a man running towards it. Let's work on these one by one. When the train is crossing the stationary man, since the man has zero length, we will consider the crossing distance as the train's own length. Converting speed into meters per second and using this along with the crossing distance, we can calculate the length of the train as 100 meters. Now let's use this in the second crossing situation. When the train is crossing the running man, note that the distance taken to cross will still remain the same 100 meters. However, now we will use the concept of relative speed. Since the man runs towards the train, relative speed will equal the sum of these speeds. That is 10 plus 6 or 16 meters per second. Using this along with the distance, we get the time taken as 6.25 seconds. Let's now look at our next problem. In this case, a train is crossing another train which is also moving in the same direction. In this case, crossing distance will be the sum of their lengths. Hence, we are given that the second train is of double the length. Crossing distance hence becomes 450 meters. Also, the speed of the first train is given to us in meters per second, but the speed of the second train must be converted into meters per second as well. Now, relative speed will be the difference of speeds, that is 5 meters per second. Using this in the formula, crossing distance equal to relative speed into time, we compute the time, we get the time as 90 seconds.